This is the review for the different types of operations for finding derivatives. So we have our different rules for finding derivatives. And sorry if the audio sounds a little different. I am using my AirPods for this video, but there's three main types of ways, different types of methods in order to find derivatives. You have your product rules. Oh, let me get the draw out here. Products rule. Your quotient rule, and your chain rule. And I'm just going to go through each of these quick just to give a quick refresher. So let's start with, first of all, just how to quickly find a derivative. So you'll be given something like this, y equals 4x squared. And they'll 4x squared plus 6x. And they'll ask for what's the derivative of that. So that can either be written as this or this. Both means the same thing. It's just what's the derivative. It's the symbol for derivative. But for now, we'll use this symbol. So y prime. So in order to quickly do it, you take the exponent and multiply it by the coefficient. So 4 times 2 is 8. Keep the x, and then you subtract whatever the exponent is by 1. So 2 minus 1 equals 1. So obviously we can get rid of that. So we're just left with the x. So then we come over here. The exponent here would be 1, right? Because anytime that you don't see an exponent there, it's just 1. So then we do 1 times the 6 to get 6 times the x, right? But then when we go to the exponent, it's 1 minus 1 equals 0. So it's x to the 0, which, as we know, anything raised to 0 is just 1. So you end up with 6 times 1, which can just be rewritten as 6. So that's just a quick intro of how to find a derivative the quick way. And that's important to be able to do with the other methods. So let's move on to the product rule. Product rule. So the product rule is used when you have two different things that are being multiplied by each other. Obviously, products comes from multiplication. And so let's say you have like y equals e to the x times the sine of x. The rule for the product rule is going to be first times the derivative of the second plus the second times the derivative of the first. I don't know why I wrote the first one out and I didn't write the other ones. It's going to bother me, so I'm just going to change that first. So that is the general rule for the product rule. Write that down, memorize it, do whatever you need to do. Yeah. So anytime you see two things being multiplied by each other, immediately think product rule. So the main thing that should be popping up right now is, what about when we had something like this, 6x squared, right? Because aren't you multiplying the 6? Isn't this the same thing, these two things? And the answer to that is absolutely. So you're going to ask, why aren't you using a product rule for that? So let's just use the product rule for this. Because remember, we said that doing it the easy way, it would be, what would that, 12x, right? That would be 12x. So let's follow the product rule and see if we get that. So we got first 6 times the derivative of the second. So that would be 2x plus the second x squared times the derivative of the first. But the derivative of any just number is going to be 0, right? Because if you think about it, this can be rewritten as like 6x to the 0, because x to the 0 is just 1. So then when you multiply this, you end up getting like 0, whatever. It ends up being 0. So because there's no x there. So then when you multiply this out, you end up getting 6 times 2x. And then this whole second half drops out because you're multiplying by 0, and you get 12x. So when you see something like that, where we did the quick way, That's actually a product rule, but it's just not fully brought out. But now that I went through that, let's do it for a more difficult one. So you have to remember your different derivative rules. So first, e to the x, this is the first term. This is the second term. First times the derivative of the second, derivative of a sine is a cosine, plus the second cosine. Sorry, not cosine, my bad. Don't do that. Times the second, so it'll be sine of x. Don't want to take the derivative there. Times the derivative of the first, but the derivative of e to the x is still e to the x. So that would be our answer. And always go back and just check it with this. So we have our first times the derivative of the second plus the second times the derivative of the first. Yep. Okay, looks good. So now moving on to the quotient rule. And if you ever just, if you're ever struggling, you can always go back. I'm going through these very quick because I don't have a lot of time tonight and there's a lot of stuff to cover. There's going to be another video that covers the logarithmic differentiation and implicit differentiation. So I'm just going through these quick. So now we have the quotient rule. So the general rule for this is bottom. Sorry, that's not B. Bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. So I'm just going to put this off in a little box here. And a good way to check that you have it the same way is that you'll see that the bottoms will form a kind of triangle, right? Where they're all on the outside, bottom, bottom, bottom. That's just a good little check. I don't like the songs or anything because it's too easy to mix up. Just remember, you got your bottoms that form that little triangle there, and then in between you got the two tops. So let's say we have something like y equals the cosine of x over 6x cubed. Okay, so we have the equation there. So we're going to do y prime equals, y prime again means the derivative equals bottom. So 6x cubed times the derivative of the top. The derivative of the cosine of x would be the negative sine of x, right? Minus the top. So that would be, sorry, my printer's printing right now. Minus the top. So that would be cosine of x times the derivative of the bottom. So that would be 18x squared. All over the bottom square. Always use parentheses. Parentheses are your friend. I can even put something like this in parentheses just to be extra sure. Actually, you're going to want to put this in parentheses so that it doesn't look like minus the cosine of x times that. I don't know if that really matters. Just the more parentheses, the better. So we're going to go back and check this. So we have bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Yep, looks good. So again, remember these rules for the quotient rule, and then you just plug into it. It's pretty simple. Okay. And I don't know if I went through this, but when I say bottom, I mean the bottom of the denominator. So this would be the bottom and this is the top. The bottom is the denominator, top is the numerator of your fraction, because remember, when you have a fraction like this, you're really dividing. And again, the quotient is the answer to a division problem, so that's where that comes from. So now we're going to move on to the last one, and that is going to be the chain rule. So we have chain rule. And when the chain rule would be used is when you have something in that's being, let's say, raised or being differentiated that's not just an x. So before we had something like this, 3x squared. And we see that the x is what's being squared here. So we were able to do 6x, we were able to do this times this, and then the exponent minus 1 to get 6x. But that's all fine and dandy until you get something like this. 3 times, let's say, the sine of x squared. You'll see that it's the same thing that I wrote before, except now instead of the x being in here, it's sine of x. So how would you do that? You would have to do the chain rule. So what's the chain rule? The chain rule is if you have something like a times whatever's in the parentheses raised to the b, what you're going to do is you're going to do a times b times the parentheses raised to the b minus 1 times the derivative of the parentheses. Okay. And when I say the parentheses, I mean whatever's being squared here, whatever's taking the place of the x. So if I had like sine of x as opposed to like the sine of 3x squared, this now is what's in the parentheses, because remember originally it was x, but the x is being replaced by that 3x squared. So whenever I say parentheses, that's what I mean. So this is what we want to be plugging into for our chain rule. So we'll have y equals 3x, 3 times the sine of x raised to the second. So we'll have y prime equals 6 times the sine of x. Remember, we're not changing what's in the parentheses. All raised to the first. You can get rid of that because you don't need that because it's just the first. Times the derivative of whatever's in the parentheses. Derivative of the sine of x is the cosine of x. So that's how we do that one. So let's go to, I'm just going to do another example just because this is the one that tends to be trickier. Let's say that we have the, hold on, let me think of one. Y equals the cosine of e to the x. So how would you do this one? You just follow the same exact procedure. And you can keep doing this. Let's say instead of e to the x, it was e to the 4x squared. Okay. So now I know this one looks like a mess, but you can have as many chain rules inside chain rules as you want. And all you have to do is just take it one step at a time and plug it into this formula. So we're going to start the derivative equals. Actually, for this one, it's not going to be that formula. For this one, since we have a cosine in front, what we're going to do is we're going to take the derivative of this. So I guess this is the second form of the chain rule. It would be whatever the derivative is in the front. So we're going to take the derivative of the cosine, negative sine. But the general rule is the same, times whatever's in the parentheses times the derivative of the parentheses. Before I go on to figuring out what the derivative of the parentheses is, I just want to explain why it's a little different. When you're multiplying a and b here, what you're doing is you're finding the derivative of those two numbers. But since we're no longer using numbers and we're using a trig function like cosine, instead of being able to multiply them to find the derivative, you just have to find the procedure. You have to use the procedure for that specific trig function. So it's the derivative of whatever's in the front times whatever's in the parentheses times the derivative of that parentheses. Okay, it's a little tricky to follow, but just stay with my example here. So we have negative sine times the parentheses times the derivative of the parentheses, but we see that it's not e to the x, right? It's e to the 4x squared. If it was e to the x, it would just be normal. But again, that x is replaced by 4x squared. So instead of that, we got to use another chain rule. So we're going to have e to the x, the derivative of that is going to be e to the 4x squared. Remember, that's our parentheses now, so we're going to keep that common. Times, now we have to find the derivative of this parentheses, right? So the derivative of that would be 8x. So this would be our final answer. That was a rough one, but I think that if you just are, if you're able to follow along with that, you can do any chain rule. And then when it comes to doing product rules and side chain rules, or product rules within quotient rules, if you have something that looks like this, 3x squared times sine of 4x over, I don't know, e to the x, this is a mess. But all you have to do is just break it down. And you see that it actually is just a combination of the different forms that we use. We have product rule, quotient rule, chain rule. So we'll do like bottom e to the x times the derivative of the top. But we'll see that to get the derivative of the top, since these are being multiplied, we have to do the product rule. And I don't know if I said this in the beginning, but since they're being divided, you should start with quotient rule. So that's where I got this bottom from. I'm not actually going to go through this whole thing. I just want to explain the whole thought process. So you'll use the product rule in order to get the derivative of the top. And then when you're doing the product rule, you actually have to do the chain rule inside of the product rule, right? Because anytime that it's not just an X, you have to use the chain rule. So that's just an example of when you would have different rules inside of each other. But that's not difficult if you just remember what the individual rules are and you take it one step at a time. And don't try to rush through anything. And always make sure to go back and check your work anytime you have something like that. Okay.